Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions for AP Physics 1 exam. In this lesson, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together. Let's improve together. Question 39 says a person holds a 4.0 kg block at position A shown above on the left in contact with an uncompressed vertical spring with a spring constant of 500 newtons per meter. The person gently lowers the block from rest at position A to rest at position B. Which of the following describes the change in energy of the block spring earth system as a result of the block being lowered? So we need to calculate in this case the change in energy. So when the block is at this point, spring is not compressed, so only energy this block has this system has, that is GPE. And when the block is at this point, it has GPE, so we can say it has GPE and also it has EPE. But in this case, the smart way is if we take this line as our reference point. If we take this one as our reference point, so we can say GPE at this point is equal to 0. So it has GPE here, but EPE at that point is equal to 0 because spring is not compressed. So in this case, we can calculate loss in GPE first of all. We can write down loss in GPE. Loss in GPE will be equal to mg delta H. And delta H in this case is equal to 10 centimeters. So we have 10 centimeters, 30 minus 20. And this one is equal to 0.1 meters. Now simply we can plug in values. In this case, mass of the block is given, that is equal to 4.0 kgs, and we have value of G, that is 10 newtons per kg, and delta H is given, that is equal to 0.1 meter. If we simply multiply this one, we will get 4.0 joules. So this is the value of GPE at this point. So this is 4.0 joules. We can also calculate gain in EPE. Gain in EPE. Gain in EPE, this will be equal to 1/2 K times delta X square. But delta X square in this case means how much spring has been compressed, that is equal to delta H. So we can say this is equal to 1/2 K times delta H square. This much spring has been compressed. So we have values of K, that is equal to 500, and value of H we have, that is equal to 0.1 square. And if we solve this one, we will get this is equal to 2.5 joules. So now we need to calculate in this case loss in energy. So I will be writing here loss in energy, or we can say change in energy. Loss in energy of the system, or we can say change in energy. So the loss in energy in this case is equal to 4.0 minus we have 2.5 joules. 2.5 joules. So we will get this is equal to 1.5 joules. Means energy has been decreased by this much approximately. So if you look at given option, the energy decreases by approximately 1.5 joules. This is right. So the answer for this question is A. This one is incorrect. This is also incorrect. Energy of the system does not change. This is also incorrect. So the answer for this question is A. This question is simply based on conservation of energy. Question 40 says the stocks of boxes shown in the figure above are inside an elevator that is moving upward. The masses of the boxes are given in terms of the mass capital M of the lightest box. How does the magnitude of the force exerted by the top box on the bottom box compares with the magnitude of the force exerted by the bottom box on the top box for each of the stocks? So in this case, first of all, we can simply imagine we have a block M. Let's say this is block M, and we also have another block that has also mass capital M as given in figure 1, as given in this arrangement. So in this case, we can, this is our top box, we can say this is top one, and the lower one, this is the bottom box. Top box will push on the bottom box, so this one is our bottom box. It will be pushed by top box by force mg. And now if we draw the top box, here we can draw the top box, so it also has mass m, and the bottom box will push on this one upwards with the same magnitude of force. So this will push this one upward with the same magnitude of force, that is mg. Because these forces are action and reaction forces, they are the same type of forces, they are acting on two different objects and they are acting in opposite directions. Now simply we can say these are Newton's third law of air forces. Newton's third law of air forces. Newton third law air forces. So these are Newton third law air forces. Now if you look at this block, maybe this one is a little bit complicated one. So for this block we have this arrangement. We have 4m mass, so this is 4m, and we have here 2m, so 2m is placed at the bottom. So in this case, the force on the bottom box, it is pushed by the top box by force 4mg. So this is 2m, and the force on the 4m box, force on this one will be equal to 4mg as well, because these are action and reaction forces. These are same type of forces acting on two different objects but acting in opposite directions. So each box will experience, so this one, the force on this one is 4mg, the force on this one in the upward direction, if I draw here, this will be 2mg, and force on the bottom box, force on this one will be, here I can draw this will be 2mg as well, and the force on this one upwards will be 2mg, this one will be 2mg, and the force on this, the bottom box, this one also will be 2mg. So this is how you need to understand this problem. In this case, these forces are action and reaction forces and they form Newton's third law of air. So that's the reason these forces are equal in magnitude and opposite in directions. So the answer for this question, now we need to figure out the answer. For option A, it is given to us the two magnitudes are always equal in each of the stocks. Yes. So the answer for this question is A. Question 41 says, assume the elevator is moving at constant speed and consider the bottom box in the stock that has two boxes of mass 2m. Means we have to consider this stock. Let F floor be the force exerted by the floor on the box, Fg be the force exerted by gravity on the box, and F box be the force exerted by the top box on the bottom box. Which of the following best represents the forces exerted on the bottom box? First of all, we need to understand it is given to us that box is moving at constant speed. Constant speed simply means that net force is equal to 0. So very important point. So net force is equal to 0. So the forces on the bottom box are balanced. Now if we draw this arrangement again, mean this stock again, so we can draw these two boxes and we will focus on the bottom box only. This is 2m and here we have the ground. So this one is the ground. This is the ground. So in this case, first of all, the force acting on this box is the force of gravity. We can say this is Fg and this is equal to 2mg. And now there is force on the bottom box by the top box, and that force is F box, and this force also is equal to 2mg. As these two forces are acting down, there must be force from the floor in the upward direction. So we can say this is F floor, and F floor has to be equal to F box plus Fg. because this block is moving at constant speed. So if you have this understanding, we can redraw the diagram. So we can say F floor is pushing this box in upward direction, and there is a force on this one, that is force of gravity, that is acting down, and also there is force by the top box that is also acting in downward direction. So this is our free body diagram. This is our free body diagram. These are the forces acting on the bottom box. So option 1, this is incorrect because force by the box is missing. This is right, but this one is also incorrect because also the force by gravity is missing in this case. So this is also incorrect. Force by the floor upward, force by gravity down, force by box down, top box. So this is our answer, and this one is incorrect. Gravity is down, force by the box is down, not up. So this one is incorrect. So the answer for this question is C. This is how you can figure out. Question 42 says, assume the elevator has upward acceleration A and consider the stock that has two boxes of mass capital M. What is the magnitude of the force exerted on the top box by the bottom box on the top box? So we can draw this arrangement again. So we have two boxes. So we have these two boxes. Mass of this box is capital M and mass of this one is also capital M. For this question, it is given to us elevator is moving upward with acceleration A. So it means acceleration of this box is also A. So we can say the net force on the top box, F net, this one has to be equal to M times A, and F net has to be in the upward direction. Now if we consider the forces acting on this box, one is the gravity that is acting down, so this is equal to mg, and there is a force on the top box by the bottom box. This force is in upward direction. We can say this force is Fn, normal reaction force, pushing force by this box. So in this case, F net, this is equal to ma, and this one has to be equal to Fn minus mg, but we need to find out what is value of Fn. So Fn in this case, simply we can write down, this one has to be equal to ma plus mg. So if we take m common from here, we can say this is a plus g. So this is the force exerted on the top box by the bottom box. So it is accelerating. That's the reason Fn is equal to m times a plus g. So the answer for this question is D. Question 43 says, a researcher is analyzing data from a high energy particle collision. The result of the analysis gives a value of 8.8 times 10 to minus 19 coulombs plus minus 0.1 times 10 to minus 19 coulombs for the charge of one of the emitted particles. Should the researcher accept the value? So in this case, it is given to us that charge on the particle is equal to 8.8 times 10 to minus 19 coulombs plus minus 0.1 times 10 to minus 19 coulombs. It simply means that this charge can be 8.7 times 10 to minus 19 coulombs, or this charge can be 8.9 times 10 to minus 19 coulombs. So we need to understand charge on any particle has to be integer multiple of the charge on single electron, means n times e. So n here, this one has to be the integer, and e is the charge on single electron. So this is the elementary charge, the charge on single electron. N has to be integer number, so it has to be integer. It has to be integer, means n can be 1, it can be 2, it can be 3, 4, 5, and so on. But n cannot be 0.5 and cannot be 1.5 and cannot be 2.5. So this is incorrect. So in this case, if you look at this one, let's say we have Q. This one can be 5 times, this number can be 5. So we have 1.6 times 10 to minus 19 coulombs. So this will be equal to 8.0 times 10 to minus 19 coulombs. RQ can be 6 and can be 6, and this is 1.6 times 10 to minus 19 coulombs. So in this case, possible charge can be 9.6 times 10 to minus 19 coulombs. As this is not 8.0 and this is also not 9.6, it is between these values. So it means this charge is not possible. This is not possible. This is also not possible. Yes, it is a perfectly acceptable value. No, it is incorrect. No, because the value is much bigger than elementary charge. This is right, but this one is wrong. So this option is also incorrect. No, because the value is not an integer multiple of the elementary charge. This statement is correct, and this statement is also incorrect. So the answer for this question is C. Question 44 says the current through the 3 ohms resistor in the circuit shown above is most nearly. Simply we need to find out how much current is passing through this resistor. So value of I we need to find out in this case. So the best way to answer this problem is, if you look at this part of the circuit, we have these 2 resistors. They are connected in parallel. So we can find out the total resistance of these 2 resistors. So we can simply write down RT. RT in this case has to be equal to 3 times 6 divided by 3 plus 6. So we have 18. This is divided by 9. So this is equal to 2 ohms. So we can redraw our circuit. So we have our circuit. We have 1 ohm resistor, and then we have 2 ohm resistor. So we have 12 volts battery. This resistor is 1 ohm and this one is 2 ohm. So we can find out the PD across this 2 ohm resistor. So let's say we connect our voltmeter here. Let's say this is our voltmeter. So the value of V we can find out. Value of V will be equal to 2 divided by, means the resistance of this resistor divided by the total resistance. We have 1 plus 2 multiplied by EMF of the battery. So we have 12 volts. So if we solve this one, we will get this is 2 divided by 3 multiplied by 12. So in this case, we will get value of V, that is equal to 8 volts. So this is value of V. Value of V. So in this case, we need to understand the PD across this one. PD across this one has to be equal to 8 volts, and PD across this one also has to be equal to 8 volts. So this also has to be equal to 8 volts. So we have the PD across this one, and we have resistance of this resistor. So we can find out value of current. So PD across this one is 8 volts divided by 3. So we will get this is about 2.7 amps. 2.7. So we can also check this. We have 8. This is divided by 3. So if we solve this one, we will get 2.6. So it's very close to 2.7 value. So the answer for this question has to be B. So B is the right answer. So this is how you can figure out. Question 45 says a student wants to determine the speed of sound at an elevation of 1 mile. To do this, the student performs an experiment to determine the resonance frequencies of tube that is closed at one end. The student takes measurements every day for a week and gets different results on different days. Different results means student get different values of speeds at different days. Which of the following experiments would help the student determine the reason for the different results? Means the reason for different results. what kind of experiment student can arrange to find out why his results are different. For that purpose, we need to understand the speed of sound. It depends on temperature. Speed of sound. It depends on temperature. Depends on temperature. Depends on temperature. And temperature, different days, temperature can be different. Temperature can be different on different days. So in this case, temperature is uncontrolled variable. Student is not controlling temperature. So temperature is uncontrolled variable. So due to change in temperature, speed of sound is different, and that's the reason his results are different. So student needs to control temperature, and he can verify this one by doing experiment for a certain period of time on certain days when temperature is same, means temperature is 10 degrees Celsius or temperature is 20 degrees Celsius, and he can repeat the same experiment for same number of days when temperature, let's say, is 40 degrees Celsius, and then he can compare the results. If the results are different, it means temperature is affecting the results. So temperature is the reason behind different results. So simply in this case, student needs to control temperature. So if you look at given options, for option A is given, it is given to us repeating the experiment on several 10 degrees Celsius days and 20 degrees Celsius days. So if student do experiment for certain days when temperature is 10 degrees Celsius and for certain days when temperature is 20 degrees Celsius, student can compare the results and student can find the reason behind different results. So option A is correct. Option B is incorrect. Longer tube doesn't affect. This is incorrect. Experiment using a wider range of frequencies, it will not give the reason of different results. So this is also incorrect. Repeating the original experiment for additional week, it will also not give the reason behind different results. So the answer for this question is A. So simply student in this case has to control temperature because speed of sound depends on temperature.